flat surface. So I'm going to talk a little bit about lenses and what happens when light hits a curved surface. So right off the bat, does anyone here know the difference between a convergent and a divergent lens? Yes? What's the difference?
So convergent lens, it converges the rays, therefore
Yes.
it's like that. And
Yeah.
divergent lens looks like that, so divergence lens.
Exactly. So, this is correct. Alright, so basically a convergent lens is what we think of as a convex lens, right? So basically the way this works, and what y'all learned a little bit from Snell's law, is that when light comes in, it will bend towards the middle of the lens. So when we have parallel rays of light coming into this lens, they're going to converge at one point, right?
Yes.
So for a divergent lens, it's going to do just the opposite. Alright? So, an example of a convergent lens, the first one I drew up here, is a magnifying glass, right? So when you hold up a magnifying glass, it is curved out on both sides, right? So what that helps you do is look at something and focus it, make it look a little bit bigger. So now that we've talked a little bit about convergent and divergent, does anyone know the difference between the two as far as real and virtual images go? Has anyone ever heard of a real or a virtual image before, other than like digital or something like that?
A real image is something that shows off, and a virtual image is like a mirror. Where is a virtual image?
Actually, yes, that's correct. I'll give you a little bit more of a technical definition, I suppose. So what we have with a convergent lens, right, is that when you look through a convergent lens, you can see an image that is either right side up or upside down, right? And I'll explain how that works in a second. When you look through a divergent lens, you will always see an image that is right side up. And this is going to sound a little counterintuitive here, but when you look through a lens and you see an image that is upside down, that is a real image. When you look through a lens and see an image that is right side up, that is actually a virtual image. So keep that in mind moving forward. I'm going to talk a little bit now about how these images are constructed for each type of lens.
Wait.
Yes.
Can you repeat that? With
About-
a virtual thing?
Yes,
Sorry, which
yes.
one's which?
So a real image is an image that is upside down when you look through a lens, and a virtual image is one that is right side up.
Okay.
And that has to do with where it is on the lens. So first thing that I'll introduce with lenses is the idea of a focal length, right? So for each lens, it's going to have a different length at which it focuses an image, right? And this has to do with, the curvature of the lens and the size and so on and so forth. But let's just say for now that this convergent lens has two focal points, here and here, right? So we're going to do F1 and F2. Now, if we have a object, just a little arrow here, how does this image, or I'm sorry, how does the image of this object transmitted through this lens? So this is what we refer to as a ray diagram, and we'll explain a little bit how this works. So for this situation, with the object right here, outside of the focal length, it's transmitted in a certain way, and we draw that by saying, for instance, one ray of light is going to go parallel to this central axis, which is basically a line straight through the middle of the lens. And then, once it's here, I'm going to say that it refracts through this focal length. At the same time, there's a ray that goes down through this one and refracts parallel on the other side. And at the same time, there's one that goes right which we can say come from like the top of this arrow, are going to meet over here. And that's what your image is going to end up looking like. So what happens is with a convergent lens, all of these images are, all of these rays of light are going to, refract through this lens and make an image that looks like it's upside down. Now keep in mind that we have an object that is outside of the focal length on this side, and this is the image, and it's going to make an upside down image on the outside of the focal length on the far side. So, what happens? Well, first off, does this make a little bit of sense?
What are the focal?
What are the focal points?
What is this?
Okay, so a focal, for this type of lens, a focal point is, remember the first time when I drew the parallel rays of light coming in? For instance, if they're all coming in straight, they are all going to converge at this point.
Okay.
And vice versa, if they all come in from this side, they're going to converge right here at this point. And these focal lengths have, like I was saying earlier, have a lot to do with the curvature of the lens and the size of the lens. So this is totally dependent on the lens. But that's essentially how these focal lengths work for the convergent. I'm sorry? Okay. And in a second I'll explain what's different about a divergent lens. But that's what these focal lengths are. So does it make sense that, assuming that what I said about how these light rays bend in the length, that this comes out being upside down? A little bit? Yeah? Alright. Well, we will, just take my word for it for now. But we will, we'll look at another situation real quick, or two more. So if we have the same lens, the same central axis, and two focal lengths, but now we move our object inside one of the focal lengths. Now what happens? Will it, given what I said earlier about a light ray going in and then going through the focal point, and another light ray that needs to go through this one, do you think that it's going to work the same way? No. Okay. You're right. So we're going to do the same thing here. First, we're just going to put one parallel to this axis through, and it's going to refract that way. Now, it's hard to draw a line from the top of this thing through this point and through the lens. In fact, I'm pretty sure that's impossible. But what we can do is imagine instead, we'll look at this thing real quick. Yeah, so imagine instead that we had a light, or a ray that started here and went through the same point. What that's going to do is go up here, right, and then it would refract in whatever way, right? In fact, it would be a bit that way, I believe. Yeah. And then we have our same one. It goes this way. So these are the types of lines that describe how an image is made. But if, in this situation with the object inside of the focal length, we're going to work backwards from these lines. And instead of the image showing up on this side, it's going to show up on this side. So if we were to trace some of these lines back, they would all end up looking something like this, right? And this may not be very intuitive at first. Basically, what all this means is that if you take the object and move it inside the focal length for one of these lenses, it's going to look like it's standing straight up, right? It's not going to look flipped. It's going to look normal. But that's a virtual image because that image is on the same side of the lens when you draw the ray diagram as the object, and it's straight up, which is what I was talking about earlier with virtual image being straight up. So this, again, this might be a little counterintuitive at first, but bear with me. The last example I'm going to give is with a divergent